So the purpose of this lesson is to examine what we call the rock cycle. The rock cycle is an attempt by geologists to show how the different rocks and materials at the Earth's surface are related to each other, and in effect, how one can feed the other. Here on this particular slide, we're looking at showing volcanic activity in the upper right corner, and yet in the lower left corner, we're seeing a sequence of sedimentary rocks. The rock cycle here, shown in a somewhat simplified fashion, these can get as complicated as you want. We're going to start at the left-hand side of the sedimentary rocks. So we take sedimentary rock. If we were to heat and apply pressure to that rock, it'd be transformed to a metamorphic rock. We then melted that rock, it becomes magma. The magma may then cool, and that would form an igneous rock. That might then be formed, affected by weather and erosion, which would form a sediment, and then that sediment would become a sedimentary rock. What we've done there is follow the cycle, the outer cycle. However, there are shortcuts throughout this. So, for example, sedimentary rock may have heat and pressure applied to it, becomes a metamorphic rock. That rock may be weathered and subject to breakdown and erosion, becomes a sediment, then forms the sedimentary rock. So not only do we have the major cycle, but there are small cycles within that. In other words, there are shortcuts between all of these possibilities. On the Earth's surface, there are three basic types of rock. There's igneous rocks, there are sedimentary rocks, there are metamorphic rocks. In the upper right corner, there is an example of an igneous rock. Typically, you see large crystals. Crystals are all interlocking with each other to form this dense, hard rock. In the lower right corner is a metamorphic rock. That differs from the igneous because you can see the layers. They're actually what we call foliations, or irregular layers. Each layer tends to have a different mineral assemblage in it, and that's what creates the banding effect there. Sedimentary rock, shown in the lower left corner, is formed from the breakdown of igneous rocks, breakdown of metamorphic rocks, or even breakdown of other sedimentary rocks. They're formed of grains and pebbles and everything that accumulate and then become lithified. All rocks that we look at are formed of mineral. Now, a mineral is a substance or crystal that has consistent composition and constant crystal forms. If you look at the upper right corner, there is quartz, which is a silica oxide, always a silica oxide, and the crystals that you see there are typical crystal shapes for quartz. These rocks that we've looked at previously, be they igneous, metamorphic, or sedimentary, are formed of naturally occurring mixtures of minerals. So we can take a rock such as granite, shown in the lower right corner, that is formed of a particular assemblage of minerals. For example, the pink crystals that you see in there, they are a mineral called feldspar. Likewise, if we look at the lower left corner, is a rock called gneiss. That's a metamorphic rock. The white layers there are formed of predominantly of quartz crystals, such as the ones you see in the upper right corner. It doesn't matter what type of rock, they're all formed of minerals and various types of minerals. Igneous rocks, if we look at those first, all igneous rocks are formed from magma. Spectacular displays of magma when a volcano erupts. Magma is simply molten rock. Its typical temperature is between 800 to 1200 degrees Celsius, depending on type of magma. And when it gets really hot, it can flow down the hillsides, and you can get rivers of magma flowing down slowly. That igneous rock, you can apply heat and pressure to any type of rock to produce a magma. So we can start with an igneous rock, start with metamorphic rock, start with sedimentary rock. We apply heat and pressure to it, it is eventually going to melt. Doesn't matter what rock type it is, it will melt and it will produce a magma, as we saw in the previous photograph. There are two main types of igneous rocks. There are what we call the extrusive igneous rocks and the intrusive igneous rocks. Extrusive form when the magma comes from depth, comes to the surface and flows out on the surface of the earth. As it flows out on the surface of the earth, it will cool down, commonly very rapidly, and it will form an extrusive igneous rock. What you don't see, however, is where the magma bubbles up to the surface or tries to get to the surface, but doesn't quite make it. The magma gets trapped underground. That magma will also cool down, but at a much slower rate than for the extrusive igneous material. Though that magma that cools down there will form an intrusive igneous rock. Typically, the crystal size in an intrusive igneous rock will be larger than the crystal size in the extrusive, simply because the magma that forms the intrusive rock will cool down at a slower rate than the material that comes to the Earth's surface. As you're probably well aware, these volcanic activity can be extreme, the explosions, massive amounts of magma being pushed out, lots of steam and other poisonous gases coming out, as shown in this image. So to go back and emphasize the simple way of distinguishing between an intrusive igneous rock and an extrusive igneous rock is crystal size. So if you look, you don't even need to know what type of minerals you're dealing with. If you look at the top two pictures, you can see the crystals, they're large, just defined by color. The lower two photographs is extremely difficult to see anything precise crystals. For example, obsidian in the lower right corner is a natural glass. In the olden days, they actually used to use this as window panes because it's exactly like glass. There are no crystals. The basalt that's shown there is formed of very small crystals. You're not going to see those just looking at the rock. You would need to make thin sections and look at them in detail. Sedimentary rocks form in water. So, for example, here on the left-hand side, it shows severe waves crashing in against a coastline. As those waves crash in against the coastline, they will erode away the rocks that are there. They'll produce beach, as you can see on the right-hand side, lots of pebbles of different sizes. Also, they'll produce a lot of grains that are so small that you cannot even see them on the scale of the photograph shown there. So this brings us, so we've now seen the igneous rock, we've seen the sedimentary rock, or the metamorphic rock, break those down, form a sediment, and they will become the sedimentary rock. Key issues for formation of sedimentary rocks are weathering and transportation. So to start with, you have to have a physical destruction of the rock, and in some case, dissolution. In other words, you don't just break it down, you break it so much that the chemicals come apart and go into the water. If you look at Searles Lake in Nevada in the lower left corner, you can see examples of all rock masses sticking up, but all the loose sediment that's surrounded is formed by the breakdown. Look at the river on the right, then you can see the boulders and pebbles and everything in the water. That's material that may well have come from the mountains that you see in the background, being broken down, and now is being carried down by the river. This river ultimately will go into a lake or even into the ocean. Once those sediments have been laid down and deposited, we then have to go through a process of lithification. Literally what you're going to do is take all the grains and boulders and everything else. You're literally going to cement them together. Cement is a natural cement precipitated from water. So if you look on the lower left corner, seen from East Sound and Grand Cayman, you see all the white sediment on the seafloor surrounding the coral reef. On the right-hand side, you see a sequence of what is Cretaceous, it's jaw in England. And for example, the white rocks that you see in the top there would have formed from sediment like that shown on the floor of East Sound. Red rocks below are exactly the same rock type, but they've been stained with some iron and hence turned red. We never use color to identify a rock. The color is a secondary thing that trace amounts of various elements. Metamorphism or metamorphic rocks, it literally means new rocks from old. So we can take any pre-existing rock type, we can apply heat and pressure to it. Heat and pressure in the simplest sense will have exactly the same effect on the rock. Heat will, if you just got heat, it will tend to make the partially melt or fully melt the rock, and that's what gives you the magma. If we get heat and pressure, we'll get a rock such as shown on the lower right corner. The pressure causes that, the heat causes the rock to become pliable, plastic-like. The pressure then deforms it so that we get these folded structures. So, igneous, we've gone from igneous rocks, we've looked at metamorphic rocks, and sedimentary rocks. Remember, we can apply heat and pressure to any of these. So we can actually start with a metamorphic rock, apply pressure and heat to that, and produce a new type of metamorphic rock. As I've pointed out, metamorphic rocks are formed with transformation of any pre-existing rock by heat and pressure. Pressure has the same effect as heat. And as you can see here, we've got magma coming up to the surface. As magma rises to the surface, it will heat the rocks that are around it. As you change conditions, so you will change the minerals that grow in there. You will change what we call the fabric of the rock, meaning it will change the appearance of the rock. There are many different types of metamorphic rock. In the simplest sense, they represent the transition from low temperature and pressure to high temperature and pressure. Slate, for example, that commonly used to be used to put on roofs of houses, is a low pressure, low temperature metamorphic rock. On the other hand, when we get up to the top, on the right-hand side, look at the schist and the gneiss, those are high temperature and high pressure. So here we return to where we started. I've shown you the different types of rocks and show you, in effect, we can go start with the sediment, forms a sedimentary rock, apply heat and pressure to it, forms a metamorphic rock, melts, produce a magma that forms an igneous rock, and then we can keep on going round in that circle. But also remember that there are smaller circles within that. So, for example, form a sediment, forms a sedimentary rock, forms a metamorphic rock, but then you may get weather and erosion that takes you back to the sediment. So there are sub processes going on within this general.